Okay, we are charged up and ready to go. Doggone it, more cutting-edge cosmology dead ahead, folks. It's the SBAU Astro Hour for June 29th through July 5th, number 279. And I'll get you into the program as the MC. My name's Ronnie Heron, and I'll settle back like the rest of you viewers and learn new stuff about our universe, mostly the moon this month, this week, as my buddies on the screen from the club take on and kick around fascinating discoveries and theories, NASA launches, expanding research, and plans for space. SBAU stands for Santa Barbara Astronomical Unit, a longtime telescope club that claims its home at the Santa Barbara Museum of Natural History. This Friday evening, we have our first Friday with Professor Aldana of UCSB talking about ancient Mayan astronomy. And a week and a day later, on the 11th of July, our second Saturday star party at dark. You were invited, and we have our own YouTube channel. So read all about us at the club website online, sbau.org. And this week, here's what the topics are. Do you know that craters on the moon fall into three categories? We're going to talk lunar craters a lot this week, even take you inside the moon. And we got a gravity map of Earth's big satellite. We'll take all of take you above the moon for a short-lived NASA launch involving an orbiter called Ebb and Flow. I used to watch them on television, Ebb and Flow, for the 2011-2012 Grail mission. Let's meet the guys on the screen. Here's our incredible president who serves as our professor and his entourage, Jerry Wilson. Good morning, sir.
Good morning, everybody, and good morning to my sister Joyce and my two grandchildren, Riley and Calvin, and to my lovely wife, Patricia.
Got to remember her. They're set up in the background. We can't see them, but they're in a little peanut gallery. Here's our Captain Outreach, Chuck McPartland, who's everywhere. Chuck, how's your pet?
Doing fine.
All right, she's one incredible lady, handles both merchandise. I guess we're selling out. And she's our treasurer. And there's Tom Whittemore.
Morning.
Used to be a Westmont Science Lab guy. Spent how many years out there, right?
13.
Many.
Yeah.
You've also been our newsletter editor for about 20 years, so that had to overlap.
I think more than 20 now.
Well, you were a professor with them and our newsletter guy, right? For 20 years, I understand.
Yeah, I think it might even be 21, but Chuck would know.
It's forever.
Yeah.
Chuck's our unofficial historian.
I hope you guys like the article on the sun tunnels. It's pretty fascinating stuff.
Oh, in the new newsletter?
Yeah, it might not have gone out yet to the public.
It did, yeah, yesterday.
It did.
Yeah.
Okay.
Well, what did Jerry write about?
Jerry, what'd you write about?
I'm just trying to remember.
Yeah.
I think it's going to be your August 7th speech, isn't it? Finding an extra Earth among exoplanets.
Exoplanet Earth, yeah. Exo-Earth, yeah.
It was looking at the different molecular species that survive together, the methane and
Right.
yeah.
So on August 7th, all you got to do is transfer all these pictures that you get on the talking points on the screen, and we got a PowerPoint show. And now we have our fifth member sitting down with all that Costco stuff being put away by his wife, Karen. Tom Whittemore is married to Maureen, and Tim Crawford, and I guess all four of you, no, three of you were at the museum yesterday, weren't you?
Yep.
At Palmer Observatory.
Yeah. Tim, David, and I were there. Yeah.
With how many people? Tourists and whatnot?
130. It was a big day. It was a big
Is
day.
there a fair sampling of our membership in there among those museum visitors?
No. No, it's normally just Tim, me, and David, and Jerry sometimes.
Yeah.
And the only thing you got to look at it on a Sunday afternoon is directly up, isn't it? Or at least
Sometimes there's a moon too.
Yeah.
well, sometimes the moon, you can see it. All right.
Did you guys get the little website I sent to you? That
I did.
describes the different kind of prominences, the shapes. And
Yeah.
their
I
probability.
did. That was really nice.
I thought it was a very interesting thing.
Well, I used that yesterday.
Oh, okay.
How?
It just showed different shapes of
Yeah.
the prominences.
Yeah.
And so there was one that looked like a detached umbrella, and another one looked like a big fish hook for a while. And boy, it was pretty cool.
Yeah,
Yeah.
over the course of 2 hours, Jerry, one of the prominences changed shape dramatically.
Hmm.
It was a downward thing for a while, then it went into a loop.
Yep.
Really big, probably 4 Earths long, easily.
And it looked like a pyramid to begin. It looked like the pyramid shape, and then it looked like it looked like a pyramid. Then it looked like a fish hook, and then, as Tom said, it turned into a big loop.
Loop, yeah. It's really beautiful.
How could it look like a pyramid? The big
Oh, they
rounded,
do.
everything's rounded, isn't it?
No, when it starts, it's got to come up first, Ron.
Yeah, right.
And it comes up as a point.
And
Yeah,
there was a
sometimes.
really interesting shape that Jerry sent called a hedgerow. And sometimes we see those, and they're just multiple prominences in a row.
Yes. Yeah. There was some of that yesterday, Tim, on the other side of the sun.
Oh,
Yeah, from the one we're talking about.
I see. I
Yeah.
see.
And some of the languages you're hearing among the crowd, Tom?
Oh, a variety. Sometimes I hear Russian, and I know some Russian. Um,
Wow.
Very rarely Polish, but last week there were a couple of Armenian ladies speaking their language. It was really a beautiful tongue, very whispery, very light. And so I just asked them about the roots of that. It's just clearly not a Slavic tongue, but it kind of sounded like one at first.
Ronnie, Tom being so good with languages, I have to ask him, where are they from? And he'll know.
Well,
Yeah.
Tom Whittemore's your interpreter.
He's not only that, he's also my math instructor.
Yeah, yeah, yeah. There was a family that were speaking Hindi yesterday that came in, and a little
That's
kid.
what that was.
Yeah, the little kid thought it was the moon. I says, no, it's not Chandra.
Oh,
That's Hindi for moon, Chandra.
Is Hindi like Hindu?
What's that?
Is Hindi and Hindu both from India?
Yeah, Hindi is the tongue. Okay.
Oh, it's the same religion.
Yeah.
Okay, well, something else that gets sent to us on a regular basis by our beloved president are the silly cartoons, forwarded silly science stuff. We got 9 of them. We probably
Billy,
won't-
these are profound.
Jerry, I'll let you start us off with these talking heads. Or one.
So here's this guy talking to this dot. The creator of the universe. That's me. So got any questions? Oh man, so many. What's the reason for baryon asymmetry? Why is most of the universe matter and not antimatter?
Pretty good.
Crap, did I forget the antimatter? 1 second, just let me, boom.
That's pretty good.
Don't happen to know when those two get together.
Now this one,
That's a classic.
Yeah, it's very fit. Yeah.
this is the first explanation I read for the wave particle duality. Freshmen, and they're talking about quantum mechanics. Yeah, but they just had 2 guys. They said it's 2 blind guys. They both come up to the other opposite ends of an elephant and they're trying to describe what it is. So one says it's a wave and the other says it's a particle. And the reality is it's something else. And when we go to one side or the other, we get what we expect. So
I like the guy in the lower right best.
I don't think
it's
that.
a
Well,
bowling
yeah,
ball. Yeah.
I guess it's a male elephant, huh?
He's
Yeah.
checking out the gutter. There's a gutter back there. He found a gutter ball.
Well, the one that they used in physics class was a snake and a rope.
Yeah.
That's right.
We didn't get into
And
anatomy.
they're all blind.
Yeah.
Fascinating stuff. Okay, Chuck, Mr. Outreach, pair of talking sticks. What are they
Yeah,
talking-
this is XKCD, and there's a woman and a man talking. The man says, the new topical medication makes me extra sensitive to sun exposure and gravitational waves.
Ooh.
And she says, "Oh yeah, that's a common. Wait, what was that last part?" And he says, "Here comes one now." And you see them stretch up and then shrink down, and then he goes, "Whee!"
Man gets orgasms from gravitational waves. There's something new. Funny stuff.
Yeah, these distortions are what is it? Prolate to oblate,
Mm-hmm.
because it's a quadrupole wave. The gravitational wave is because there's no gravity and anti-gravity to do the dipole.
Tim Crawford, can you explain what's going on here?
Yeah, somebody on the capsule is hungry. So they open the window and put a hot dog out on
There you
re-entry.
go. Suppose they got that. Suppose NASA's got that plan for Artemis 3
I doubt it.
coming back. Oh, I like this one, Jerry.
Yeah.
Go ahead.
Yeah.
Actually, Tom, this
Yeah,
is
be
something-
alert. The world needs more alerts.
That's right. We have a shortage of alerts. Here's the one that became. It's like a fractal, isn't it? Goes forever.
Yeah, similar.
All right,
Yeah.
then tell us what we're looking at here.
All right, you see those posters for lost pets. This is a lost wormhole, and it
Kind of watched out.
yeah, it says, "Do not attempt to capture. You'll totally screw up the space-time continuum," or something like that. And it shows lost wormhole, and there's the picture, and the picture shows lost wormhole, which shows the picture which says lost wormhole, which says lost wormhole. It's like the infinite mirrors.
Yeah.
Yeah. I was thinking that. It was like the mirror thing.
Mhm.
All right. How about who wants to take this one, Jerry?
My neighbors were listening to some pretty cool music until they asked me to turn it down.
Very little science there, but that's all right.
I had some speakers with a real wicked bass. They would reproduce sounds less than 10 hertz. And I played Saint-Saëns' Third Symphony, the introduction to that.
Yeah, with the organ.
Yeah, with the organ symphony.
And-
And people upstairs were going, "Hey, what is that?" No,
yeah, Jerry. Yeah, Jerry, in principle, you can't hear 20 hertz
yes, I
or
know
below. You just feel the vibration. Yeah.
that. Yeah.
Well, Tom, you want to take this one on and explain what's going on in this car sale?
You won't have to worry about gas prices or electricity prices with our new pullback drive model. At the factory, we put the car on the ground and tow it all the way backward until it starts clicking.
Oh, God.
Drive forward, you just release the brake and it goes.
Hey,
I thought I didn't see it, but I do remember that. Thinking of those old toys.
Yeah.
well, who wants to do lab rules?
These are the lab rules.
Okay, here we go.
Never lick the spoon.
No.
Hot glass looks just like cold glass. If you don't know what you're doing, at least do it neatly.
Right.
Hiccups and pipettes don't mix.
That's nasty.
Assume all unmarked beakers contain a highly toxic fast-acting poison.
Whoa.
You can't detect an odorless gas by smell.
Yeah.
Nope.
If you don't know what a button does, do not push it. So I could go on.
Okay.
I could go on with lab incidents of all these things,
Mm.
but I won't. Oh, that's the last one. Okay, good.
That's number 6 out of 9 you sent us, so we've got leftovers for next week. And you're going to take
No,
us to the
that
moon.
was
Happy
all.
birthday, Mr. Press.
We covered them all, Ron.
Yeah.
We did 9?
Yeah.
All right. Amazing. Somebody had a birthday, I understand. So
Yeah, Jerry, on the
Yeah.
27th. It was also the latest sunset for the year.
Okay.
Yeah.
Oh, I didn't know
That's
that.
when
Happy
I go to
birthday,
bed
Jerry.
late. What's that?
Happy birthday.
Thank you.
Yeah. Yeah.
That's why I got the talking points out early. Because the weekend was full of relatives and celebrations and lots of
Fantastic.
sugar. Well, we're going to focus today on the talking points on the moon.
Mhm.
And this, of course, is a near side and far side of the moon. And as we know it today, it's got a lot of features on here that are historical.
We're not seeing it, Jerry.
Oh, dang,
Must have been an eclipse.
Yeah.
it was. Okay, you see it now?
Oh, yeah.
Okay.
2 versions.
So there's that. And now we're going to stop seeing that for a second.
Okay.
Stop sharing. And then we're going to go.
I got in the mood by putting the moon behind me.
Yeah. In honor of the World Cup, we do have that soccer player on the moon showing.
Uh-huh.
Hmm.
Just a second.
Oh, yeah.
Not Messier, is it? Or Messi? What's the
And the
name of
moon's
that
pretty
soccer
messy.
Yeah, from Argentina. Yeah, he is Lionel Messi. He's amazing.
The man's in his 40s, isn't he?
He's still good. He'll just dribble the ball right through you without you being able to touch it. Or he intentionally makes you touch it because it'll bounce back to him. He's really tricky.
Okay. Page 2.
Huh.
Looking at a video on YouTube.
Yes. Oh, dang. I got a lot of pop-ups here from space.com.
Hmm.
So this is a simulation of Theia hitting the Earth and
Oh,
forming.
nice.
Jesus.
And it reflects an early stage of our solar system where it was the one that's going to become the moon is this one way over here.
Oh, I see.
And this one's moving toward the Earth. It's accelerating this glob this way, which gives it the sideward motion to go into orbit around us.
Huh.
That's the one thing we've never seen a real picture of, isn't it? Two bodies
Not likely
like,
to either.
I guess not.
So again, this is going to be the moon out here. It's a very highly detailed, take a supercomputer to do it. This is the Earth with a lot of Theia coming, a lot of material coming back to the Earth.
Wow.
Wow.
Now, what this means is that the solar system has still got a lot of debris in the disk. It's not formed its planetary system in its final form yet. There's two things that have to go on. One is all the debris and stuff that's splattered out from this collision and many other collisions, that has to be all swept up. And so we get, while that happens, that's after the moon forms, which is just a minute here. So you can see the moon is now starting to take on a shape, and it's clearly in an orbit here. So,
Wow.
And I've seen a similar simulation where they show two moons forming, one smaller, and they kind of they're nearly co-orbital, and then perturbations from the sun and Venus cause that smaller one to smack into the other moon.
okay.
It's a really low speed collision, so you don't get the vaporized rock and everything. It just coats the backside of the far side of the moon with silicates, and that's why you get the thicker but less dense crust on that side.
And one of the things I saw long ago was the predictions of Theia hitting, and they wanted to predict by lab models why it just didn't pulverize the Earth, and it
Well,
had
it
to be.
did.
Yes.
Well, this one explained that if it were a direct hit, it would have pulverized and just kind of vaporized everything. But they were saying it had to hit at an angle at a certain speed.
Well, it did vaporize everything as you saw in that simulation, but that's to explain the angular momentum is to get it hitting kind of at a
Offset,
glancing
yeah.
blow, near glancing blow.
It also defined the Earth's rotational period.
And the tilt.
Yeah.
Oh,
Can you see this, Cher?
Yes.
yes.
Okay, good. So anyway, the two sides, as we'll see later, this is the heavy side, and it hangs down toward Earth's gravity. This is the back side, which is lighter, more highlands, less of these impact sites. Now, the three major periods of the moon's formation are what we just saw, the primary accretion rate, which is from 4.5, which is the date at which this started. Moon formation approximately 4.5 billion years ago. And then the initial sweep up of leftover planetesimals and debris formed things such as the South Pole Aitken Basin and a lot of the large craters. But this is the primary accretion. This is the early heavy impact formation. A lot of craters were formed. Then after there was a second late heavy bombardment, referred to as the lunar cataclysm, spike in resurgence of impact flux across the inner solar system. And this is the second step that they believe happened in the formation of our solar system, is that the major orbital reorganization of the giant planets, that is Jupiter, Saturn, Uranus, and Neptune, that's the order they are in right now from the sun. But this is not the original order. And it may even be possible that we had a large Jupiter or Jupiter-sized object interior to the small planets we have now. So they're guessing by this time of what's from models about what created different crater set of bombardment events on the moon. So the late heavy bombardment, then there's the post-bombardment, which they're running out of material down to 3.2 billion years. And this was where the Maria were formed. They're a large number of large asteroid collisions and they hit on the same side of the moon. So they probably also hit at once in a formation. Might have been a multiple moon or multiple object. And that ended in it broke through the crust. The lava came up through the broken crust and filled the Maria. And the mass that hit the Earth is now called a mass con, or mass concentration, and it's under the major Maria. So the moon is not a homogeneous thing. It's got interior structure.
Lumpy mashed potatoes.
Lumpy, yeah, that's good. Now, these are just things I put in for fun. There's two sets of things from a French Facebook friend, Robert Cazellac here. He has a 12-inch Meade, and he takes excellent pictures of different things on the moon. And he compares them to, this is from the Lunar Reconnaissance Orbiter. This is from a spacecraft. And this is the same region from his 12-inch on Earth in France. So he does a great job with this. This is, again, a Lunar Reconnaissance Orbiter here, looking at this crater. And of course, you can see a lot of boulders here. This is from his, I think this is the crater Copernicus.
Yeah, it looks like Copernicus.
Yeah, Copernic.
With the terraced
inside wall, yeah. So a lot of this structure, now the large crater Copernicus, that was formed early on. Now, a section on the talking points is new craters. These are things that have hit recently in the last few years. And these are observed, not that they didn't observe the collision, but these were named and unofficially named by the Artemis II astronauts. And so this one is the once in a craters thing observed. It happened in the spring of 2024. It's 225 meters across. This is the official size of the impact crater, and this is the size of the splash zone, the stuff that comes out. And this is a pretty large crater for happening now. This is a probe of depth from the spacecraft. And so this is, let's see, the blue one is going right across here from bottom of the picture to top. You can see it goes up over the rim, then it goes down through the crater, elevation from about 845 to 885, so about 40 meters deep. And then the other side going up and then back onto the moon's surface. This red line is where they probe going around the lip of the thing. So it gives azimuth angle from the north, 0 to 360 degrees around. So if you were trying to hike around the highest point, this is how it's distributed. So you see it's slightly offset. There's more here than here. And you can see there's more ejecta here than here. So this thing is believed to have hit at about 35 degrees from vertical.
Good question.
Yeah.
The same rocks that they say brought water to Earth and gave us our oceans had to have been hitting the moon too. And the only place where the moon kept the water would be the poles, right? South Pole.
Kept
Everywhere
the
else,
ice. Yeah.
it vaporized.
Actually, there's water all over the moon.
Oh, there still is.
It's held in the soils, it's held in minerals, and there are places where it's distributed. It's little like polka dots all over the moon if you go over with a hydrogen radar.
But as a rule, water doesn't stay on a airless
No, it
surface.
sublimes directly into the air unless it's got a lot of salts in it or it's mixed with a lot of soil. So when you think of the southern areas, because there are craters that are in permanent darkness, you think of water there. It might be a glacier, but it's going to be a dirty glacier.
How do you make a hydrogen radar?
Oh, you just send out a radar beam at some wavelength, and if you get if your radar activates the molecule, the hydrogen molecule, like a microwave, that's a hydrogen radar, because you're sending a microwave beam, a radar beam. They were originally called radar ranges in there, and you're oscillating the hydrogen atom or the hydrogen molecule inside the water, and that's what gets hot.
Yeah, Tim, it just means it's tuned to a frequency that will get the most response from hydrogen.
Right.
Yeah, it's fascinating. This is really, I'm gonna sit back. I knew this was gonna be a good one.
Oh, okay. Now this is a shot of the moon. The Lunar Reconnaissance Orbiter they have a phrase for it. Oh, that's right. It's temporal analysis. And that's what it specializes in, which just means taking a picture before and then taking a picture after. And that's what happens here. This is the picture of a basin before, and this is a picture of it after. So this meteor crater seen by the Artemis crew just north of the older Roemer crater was created between pictures 2009 and 2012. This crater was formed, and it's 22 meters in diameter, much smaller crater than the 225 one.
And again, it's asymmetrical.
Yes.
Well, leave it to science to name it temporal analysis instead of before and after.
Oh, we found out when we were marketing our projects in the future, we found out you had to have a cool acronym for the government customer to retain what you were talking about. It had to be not just Jerry came up and talked about this project, so we'd work out in meetings, we'd work out what acronym, what we could do that would sort of describe the mission, but in a clever acronym. We developed a superconductor detector, and we called it the FIRST detector, FIRST, and which got a lot of attention. Never went anywhere because no one was interested in superconducting detectors on a large production scale. So
my favorite is Messenger for the Mercury mission.
Yeah.
It's something like Mercury environment, space geochemistry and ranging. It's better than that, but
Yes.
somebody really did a good job on that one.
Those things are not to be sneezed at. Customer retention. Now this one is the Carroll crater, named after the Artemis crew member who Reed, the wife of Commander Reed Wiseman, Carroll. So it's up in this part of the visible moon on our side. And it looks like this. So this was let's see, flyby in 226. It's not, oh, that's right. This was it's a new crater because it looks fresh, not because LRO got a before picture and an after picture.
It's interesting. That's the area of the moon where they were predicting that the Falcon booster might hit from a mission.
Uh-huh.
I mean, back it coming up in August.
Gonna hit, yeah.
Well, monitoring and seeing these collisions is not just a hit or miss. They've got to have somewhere telescopes that are constantly trained on the same spots on a regular 24-hour basis.
No,
You don't have
you
to,
just see that something new showed up.
yeah.
So they don't. We never see them crash.
Oh,
Yeah,
yes,
you
they
can.
do all the time. The people take, like Chuck, they take videos of things. Some people take videos of the moon, and all of a sudden there'll be a flash somewhere. And then bigger telescopes or spacecraft will go to that area, and there's a new crater there.
Yeah, during meteor showers, there's a group that monitors the moon with video.
Yeah.
And they look for multiple detections of the same flash because you can get cosmic rays hitting your video sensor that will mimic an impact. But if you get two different videos from different spots on the world that see the same flash at the same time, then you know it's an impact.
Oh, wow.
Well, the same rocks that would be eaten up and burned alive in our atmosphere would make it to the moon's surface, wouldn't they?
You're right.
Up to size what? What size makes it to the ground? 3 feet?
Just about any size on the moon.
Well, I know that, but here they're all thankfully not hitting the ground.
Yeah, it depends. Yeah, it depends what they're made out of too, along with the size and how
Yeah.
fast they're going.
I guess about 3 people now have been hit by meteors. There was a recent one, and
But
they all seem to be,
they don't
all
bring
seem
up
to be
lava
dead.
anymore.
What?
Did they bring up lava ever?
No.
No, they're not that big.
Okay.
So this is another one. It was spotted for the first time. It wasn't on the maps, but it doesn't have a fresh ejecta around it, and they don't have a before and after picture. But they unofficially named this Integrity. Oh, it's a typo there, Integrity crater from LRO. So that one is also named by the Artemis crew.
After their capsule, I
Yeah.
think.
Artemis 3 is not even going to go out there, are they? They're going to just stay down here on the Earth.
So since the Lunar Reconnaissance Orbiter in 2016 was put up there, they have found 200 new impact craters.
Wow.
Identified it. Yeah, okay.
Look at that peak in the one. Boy, that was interesting.
What, this one?
Down in the lower left.
Oh, this one, yeah.
That just means it was a really energetic impact.
And everything's very symmetrical. It was probably straight down the barrel right there.
And that's a rebound?
Yeah.
Yeah. With all that kinetic energy, everything here turns to liquid. So it's like dropping soupy mud and, with a pebble into soupy mud, except the pebble's made out of soupy mud too. And then it rebounds, and by the time it rebounds, it's cooled off enough that it becomes solid.
Yeah, wow. Wow.
Now this one, just to quote the number, the moon is not evenly distributed. There is a gap between the moon's center of mass and the center of figure. So it's off by just under 2 kilometers away. So the near side of the moon with all of the seas on it is 2 kilometers closer than the geometric center of the sphere of the moon. So what happens is that this displacement plus the other lumps of irregularity in the moon's surface, the mascons, they pull on on satellites. So it makes it difficult to keep an LEO satellite in orbit around the moon, because the orbit generally gets perturbed after a while, and they build up, and then it sends it off into some long ellipse that either leaves the moon or it crashes into the moon. So that's played havoc with some of the plans that they have to put things like gateway and infrastructure systems around the moon, like a GPS or an MPS. So you can tell where you are. They have to put them higher up. So the things that drive the asymmetry, ruin the moon's spherical symmetry, is the crust thickness. It's much thinner on the near side than it is on the far side. This brings the denser rocks of the lunar mantle closer to the surface on the Earth's near side. The mare, basalts, and volcanism. By the way, when the last impact bombardment thing happened, it ended in a volcanism on the moon, because all that lava came up through the surface to form the smooth mare. And then there's thermal difference. Recent findings indicate the deep interior of the near side remains 100 to 200 Kelvin warmer than the far side. This uneven heat is driven by the high concentration of radioactive heat-producing elements localized on the earthward side.
Huh.
That's where all the debris is hidden from the impacts. And the backside of the moon was just a innocent bystander.
Now, why would the radioactive elements be on the heavier side? Because of the heaviness?
Chuck, you're muted.
That's because I had a phone call come in. It's sort of the mantle being exposed. So the radioactive elements tend to be heavier elements, and they sank down into that.
Yeah. Yeah, okay. Yeah, that makes sense.
And they're also resonant on the super heavy impactors, the mascons.
Mm-hmm.
Well,
It's interesting that back in the 1860s, there was a very famous thermodynamic and statistical Boltzmann, I think his name was, and he tried to calculate the age of the Earth. And he did it by saying that the Earth was once a molten ball, and it was lava, and it was at 2,000 to 3,000 degrees uniformly. And how long would it take the spherical Earth to radiate that heat away and get down to the temperature that it is now? And he came up with a very short period. It was good physics, it was good math, but there was one thing he didn't know about. He didn't know that there were radioactive elements and they produce heat. So he didn't know that the Earth had a heat source permanently in it. So he just said, okay, we're just starting with this temperature and we're coasting down to today's temperature. And if that were true, his calculation would have been correct, but it was way too short because that extra source about radiation. It wasn't until around 1940s or 30s that we were able to through that type of analysis, get a accurate age for the Earth.
But only certain elements starting at a high number do radiation, right?
Well, you can have some lighter elements be radioactive if if you add some neutrons to them. Some of the isotopes can be.
Yeah. If they have a heavy friend.
Yeah.
Okay, and are all those radiating elements made in the stars before they explode, or only when they explode?
A little bit of both.
Okay.
And in winds, in strong winds from like red
radium
supergiants.
the one that Marie Curie worked with, radium, is
Yeah.
that a pretty low element? That's a natural element, isn't it?
No.
It's not?
No.
Okay.
So this is the coarse composition of the Earth with the stratifications. It is, what do they call that when it differentiated? When it was hot and molten and all its heavy stuff sunk to the center, we get a iron core, a rocky mantle, and a crust.
Maybe some gold down there.
Looking for that in the center, yeah.
Wow.
There, and these planets and moons, when they formed, they differentiated if they lasted long enough. And then when there was a collision, like Theia and the Earth, but it was more total, it ripped the whole participants apart. Then you have a core, an asteroid that was the core of a differentiated planet. So all the metal that wasn't going to be in the planet is all in the core, all the gold and platinum and iron and all that stuff and the lead. And that's what the asteroid Psyche is made out of. It's believed to be a metallic core of a differentiated protoplanet. And we have a mission called Psyche to go to Psyche.
Although they recently got better spectra and it doesn't look like it's quite as metal as they first thought.
There was a lot of press hype in the first one. So this is what it is made out of: anorthosic crust, zone melt of the lower mantle up here, a 350-kilometer radius fluid outer core, and 160-kilometer radius solid inner core. Now, why doesn't the moon have if it's got all this dynamo stuff inside, why doesn't it have a magnetic field? And there are areas of residual magnetic field frozen in to the moon surface in various places, but it has no overriding field like the Earth has.
Jerry, it gets heavier as it goes to the center, correct?
Yes, in general,
Well,
yes.
The heavier stuff goes to the center, yes.
Yeah.
Okay.
Did you go back to the last picture again? Is the lava the black spot in the middle?
No, that's solid.
So there is no lava in the moon anymore.
It's in the fluid outer core.
Yeah, right there.
Really? It's non-liquid in the middle, but liquid outer? Because
Yes.
It's hotter
Yeah,
down here, but it's under more compression. It forces the material together and it crystallizes.
Yeah, it's a pressure thing.
Yeah.
oh, wow.
These guys in here are just about to take their math test.
So all your heavy stuff is in the middle of any object. Your iron, your gold, your lead.
If it gets hot enough to differentiate, yeah.
Yeah.
If
Now,
it's fluid
notice-
enough that stuff can move through it.
This reminds me of Christmas
Yeah.
under the
This
tree.
this is a gravitational map of the surface of the moon.
Wow.
The red are strongly gravitationally attractive features. The blue background is stuff that is not so gravitationally attractive. The average is this yellow in between. And you see that if it's forming, if we're trying to put a satellite in low moon orbit, LMO, it'll come across here. And when it comes by, it will rotate around. It'll get attracted more strongly to this area than out here. So it gets its path interrupted. So it's hard to maintain a perfectly spherical position in a low Earth orbit because of all this clutter and the very complex gravitational field that it's trying to fly in. So for that reason, we keep things higher up in orbit. But this has the mass concentrations under the seas. We'll see that again. Yes, go ahead, Tim.
I think this is a good question. These show the gravitational, so probably heavier spots. Is there a magnetic pole on the moon? Is there magnetism on the moon?
Just relic stuff.
Yeah, that's a good question. I don't believe so. The moon does not have a magnetic field that you can measure as easily like the Earth does. The Earth has a magnetic pole. I don't believe the moon does. But anyway, these are gravitational variations,
Yeah.
not
Okay.
magnetic variations.
As far as the magnetic stuff, though, there are a couple of spots where there are rocks. You know, we measure the changes in the Earth's magnetic field, you know, the North and South Pole flipping and stuff, by looking at rocks along the zones where the spreader zones in the middle of the Atlantic Ocean, for example, where new lava comes up and
Mhm.
congeals. And that keeps a record. You get a frozen record of the previous magnetic field. And so there
Wow.
are some places where there are rocks like that on the moon that have preserved a magnetic field that's strong enough to shield it from some of the incoming solar radiation. And so the soil gets a little different coloration under it. And
Yeah.
so that's a spot where you can measure some magnetism, but mostly it's weak and disorganized.
Okay. Very, very interesting.
And on the moon, gentlemen, there is absolutely no tiny little filament of an atmosphere left.
Yes.
Like, is there something
There,
above?
there, well, sort of. There's an exosphere. So you get little bits of oxygen and stuff like that, but tiny, tiny amounts. And you also get, as the terminator passes across the moon, the day-night spot, you
Mm.
get stuff that comes up and kind of swirls around like dust from
Huh.
from spalling and static electricity. So there's a little cloud that kind of moves around with the terminator.
God, whoa.
NASA claims that the moon acquired an atmosphere in July 1969 and it consists of rocket exhaust. This is a picture, representation of a model of the differentiation in progress of the moon, where it's liquid enough everywhere that you get these subduction and zones where the heavier stuff heads down toward the center from where it lands and concentrates in the center.
Well, does our Earth have similar?
The Earth went through a
Problems.
similar stage. This is, I don't see it on here, but this is at 100 million years of after the moon was formed.
The collision, huh?
So it's still adjusting itself internally. Hot, heavy things are moving toward the center, and lighter things are moving toward the outside. It's in the talking points.
Well, did you suppose old man Drake had the moon as part of his formula for life? Would we have life down here if we didn't have
I
that?
don't think there's a term for the moon in the Drake formula.
That would
There
sort
is
of go into the one of the factors, but
Yeah.
not separated out.
All right, so these exoplanets you're looking for better have a big satellite.
No, not necessarily.
Not necessarily. Okay. What's
It
happening
helps.
here?
This shows kind of a blurry picture of our moon. You recognize the major seas up there. And you can kind of, if you squint, you can see the man in the moon. There's a big old smile, nose, eye, other eye. Anyway, and this shows the mass concentrations. Can you see this, or is it washed out?
It's a little washed out, but not
Okay.
horrible.
You can see it, yeah.
Okay, so this is the mass concentrations in it under the seas, and then the highlands up here that are just crust. And this shows the resulting volcanism. And what it looks at is this square pattern around the edge, square pattern. That is the rift zone where this region got smashed up. The crust of the moon got crushed by all these massive hits. And this part of the moon stayed sort of uncrushed up. And so this is where the seas formed. And
That really that seems it seems unlikely, but if you said if they all if it hits as a group, that would explain it.
that's just my guess. I've not read anywhere that it hit as a group, but this thing is rotating. It's projecting different faces to this cosmos. And if one thing hits and 1,000 years later, another one hits, the chances of them all being within one small area on the moon, I think, are very small.
Hmm.
So I think it was something flying in formation that hit. Bam, bam, bam.
It's just amazing that it's that square.
Yeah.
It
Well,
just
part of that could be the crystal structure of the rocks too, that determines how they fracture.
Yeah. Okay.
Oh, okay, got it.
So this is that rift zone on the moon. This is like on the Earth, the ring of fire around our plate tectonics in the Pacific Ocean. But
Oh
the moon
yeah.
does not have plate tectonics. It does not have that active a geology. This is a graphic of an artist impression of part of that rift zone of the end of the Vulcan era, where volcanic tubes were forming and collapsing. So this is the ancient Rift Valley that is shown in blue here. Oh, in blue here.
Jerry, I want to return to what you were talking about Theia, and I'd also heard theories that the Pacific Ocean itself is where Theia hit because of the depth and size.
No, that impact would have vaporized everything.
Yeah, there's
Okay.
no, Chuck's right, there's no memory of the pre-hit Earth. It's just all solid liquid.
But that may have been, the Pacific Basin may have been helped out by large impacts, just not as big as Theia.
But
Okay.
the Earth has had several periods. If you've seen these videos where the plate tectonics is speeded up and you can see the continents moving around and juggling for position,
Yeah.
they go all over and they mash together and then they expand apart. And so,
Yeah, I remember that. The time lapse. That's really a neat time lapse.
now a lot of the gravitational stuff and a lot of the heat generation, especially the gravitational stuff, was measured by Apollo astronauts, but primarily by the Grail mission. And the Grail mission was a pair of satellites that orbited the moon in formation. And when they pass over a place, say where there's a mass con down here, so they get a little stronger gravitational pull, that changes the distance between these two satellites. And so they have an interferometer where they can measure very sensitive changes in their position relative to each other. And that's where they developed all these gravitational maps, was from going from here to here. And that is, the Grail mission was launched in September 2011 and ended in 2012. It orbited the moon at 34 miles and it was the impact site. They crashed it on purpose. And the impact site, do I have a picture of that? Oh no, but anyway, this is Grail A and Grail B, and it was renamed Ebb and Flow in a contest. And this is the winner of the naming contest,
Huh.
a fourth grade class, Emily Dickinson Elementary School in Bozeman, Montana.
Oh,
And you do have a picture of the impact
Yeah,
mountain
coming up,
yeah.
So now, because of the orbit, they have to get these things set and get them into lunar orbit in a very precise formation before it gets disrupted. And this is how they launch the two, Grail A and Grail B. And yeah, so anyway, this one went up, the red one came down. Wait a minute. Yeah, this is where they got inserted into blue and red, got inserted into orbit. But
flying next to each other.
yeah,
In other words,
and I'm a
parallel
little
orbit.
confused, so we're going to skip that.
maybe that's why I don't remember this one. So I got confused.
Anyway, this is the Grail impact site, and it has been named in honor of Sally Ride, who was instrumental in development of the Grail project.
those two different seeming paths there were depending on what time they managed to launch them, apparently. So there were two paths they had to take depending on whether they were early or late in the launch window.
Yeah.
Oh, they went up in two separate rockets?
No, it was one launch.
Oh, one launch. Okay.
Okay, but here's what's confusing about me, or confusing. See, this one is blue. It goes up and it comes down there blue, and then it joins this blue one to be the blue satellite.
Well, that's see, one says open and one says close.
Yeah.
So the first trajectory is if they launched right at the opening of their launch window.
Oh, I see.
And the other one's the trajectory they would have to take if they were near the close of their launch window.
Yeah.
But they both, of course, converge because they wanted to have the same final orbit at the moon.
Right. Okay, good.
So it's kind of a weird diagram.
Yes, you
They
say
should have just shown what it did, depending on when it was launched.
But they didn't have cameras on board. Just
So the one that actually did was the open one.
We don't know. I don't know if it
Yeah.
launched at the beginning of its window or at the end.
Okay.
do you know what Grail stood for?
Oh, yeah, it's an acronym.
Okay.
You can bet there's gravity in there.
Yeah.
Okay, God, that's the G.
And L for lunar.
That's how they found out there's all these mottled spots on the moon's surface that are intense gravity. But not by much, just a little bit heavier, perhaps. I wonder if that's going to affect where we land Artemis.
Not really.
Probably not.
no.
The
Did they-
primary idea there is to get someplace flat. Okay, yeah, it stands for Gravity Recovery and Interior Laboratory.
Okay.
Wow.
So it doesn't say it doesn't apply to Luna.
No.
Okay.
Ebb and flow. There was a waitress in a sitcom called Flow, but it was just FLO, short for
Yeah.
Florence.
That was a completely unrelated to us.
I know that, but it sounds like a couple of characters. Ebb and flow.
Okay.
Those two probes you were just describing, is that what got us all these imbalance on the moon that you described earlier? A little heavier on this side?
Yes.
They got the really detailed maps of it. We knew it was there before.
And yet none of that affects the tidally lock. Or does it?
Yes, it does. The mass concentrations are on the near side.
This is the gravity map made by Grail. It's
Okay,
very high, very precise, very, very high precision.
and that's our side that we see.
Yes.
And it only lasted 1 year.
Yeah.
Wow.
It's hard to keep those things at 34 miles above there. You know, we do low Earth orbit at 150 miles here, 105. And it's hard to keep them in a stable circular orbit around here.
Mhm.
So they did it as best they could. And then after a while, their orbits were getting so perturbed, they just gave up and crashed them.
Hmm.
Once again, the red stands for what and the blue stands for what?
The blue is low intensity gravity and the red is high intensity gravity.
Okay, and so you guys would know what spots those are. Those are Maris, right? Big C's?
Yes.
Yeah, but so I'm confused. So the higher gravity would be caused by the more dense materials?
Yeah,
Yes, by lumps,
heavy
yeah.
material.
Okay.
And you have stuff like that on the Earth too. It really complicates like ICBM targeting.
Yeah.
Yeah, we once showed a interior map of the volume of the Earth with regard to material density. And there's two lobes between the crust and the core that are believed to be remnants of Theia.
Oh.
And
the
you
crust-
said earlier, Jerry, there was a difference of what, 2 kilometers? Did I hear that?
the core of the moon is offset by 2 kilometers from the spherical.
So
From
does
the
that mean
geometric
this-
center.
Yeah,
Does this
geometry. Yeah,
mean-
here it is.
Does this mean that the side that faces us Is 2 kilometers closer to Earth or less closer than the other side?
The side that faces the Earth is 2 kilometers closer to the Earth than the center of the spherical shape of the moon.
Have we ever decided, with Yellowstone being a huge volcano, is there any connection to this impact to that Yellowstone crater?
No.
None. Okay.
Well, gents, I believe this is the first time in almost 6 years or over 5 that we've concentrated on one main topic, and it was fascinating.
I loved it.
I did too. I learned a lot about the moon. We lost our 5th member. I don't know, something came up.
Well,
Actually,
he muted Ronnie, and I imagine somebody, probably a workman, showed up and he had to
that's
bail.
probably true. Yeah. Well, you can come go on the show anytime you want.
I have a quick question for Chuck. How do you handle traveling with your Tesla to distant campgrounds with are there any kind of recharge stations locally, or
There's stations everywhere. Yeah.
so you have to probably recharge when you get there?
I did. I did. I didn't really have to. I could have made it back, but there was a charging station right there at the hotel, so I just plugged in and
Nice.
Yeah, even in Cambria, we stopped at a bed and breakfast that they had a Tesla recharger.
Do you have to pay for those, or is it free?
yeah.
Yeah.
Well, it depends. Some hotels will
Yeah.
let you charge free, and some of them just have a Tesla network charger that.
And when we drive to San Diego, we'll stop, say, on the round trip, we'll stop twice, usually in LA. And there the rechargers are inside, paid to enter garages. And so you have to pay your fee to go in the garage, and it's usually way up on the top floor. And then you charge, and then you leave, and you get reimbursed for your paying to park.
Wow.
Well, I got to tell you, Abdobsonian will travel. That's us. Even though I think you had to cancel Refugio Saturday night, it turned out to be beautiful, didn't it?
It turns out, no, yeah, I canceled for most volunteers because it was looking like it was going to be really horrible conditions. But I went to show the flag anyway, and it ended up being beautiful. And David came out, and so we had 3 scopes and 103 visitors or something like that.
Wow. Good for you, Chuck. I learned a lesson. That's 2 I missed. That's one of my favorite sites, and 2 of them I bailed because of weather.
Yeah.
Of course, one was sure it wasn't good.
Yeah.
We're going to be anywhere between now and general meeting Friday?
Yeah, but it's not a public event.
Oh, okay. Then we'll meet here on the screen, those of us that are still around, still breathing and walking at our age. Even though some of us are getting old. Doggone, guys, thank you. Let's do it again. That's it for the
Okay.
SBAU Astro
Thank you, Jerry.
Hour.
That was a good one again.
Thanks,